recording. And the first question we got, and I don't know if I went over these yesterday or not, or these, I don't know. I think so because they're Sunday. So, and some of you might see that they're sent by different people, but they're the same questions that were, you know, like I say, some of these questions are really out of place. So if you're sending these questions, it's probably a good sign that you're right on target because they're out of place. 1.4, 25/13. 25 in the book, 13 online. So let's see what this one says. I've never seen this question before, so I have no idea what it's asking. A club wants to sponsor a panel discussion on an upcoming election. The club wants to have 4 of its members lead the panel discussion. This is a permutation problem. This is in chapter 6. I don't know why you're even, I'm sorry. To be fair, however, the panel should consist of 2 members of each party. Below is a list of members in each party. Obtain a stratified sample of 2 people from party 1 and 2 people from party 2. And the first question says, which of the following is a possible list of club members to lead the panel discussion? Okay, well, there's umpteen different combinations and permutations. Since, let's see, they not order, so it'd be a combination. And they don't have all the combinations listed over here. So that tells me that the question is asking you to deduce a little bit, to see if there's any repetition, to see if there's anything that doesn't look right. It says 4, so let's make sure all of them got 4. Yep. All of them's got 4. Okay, they said they want 2 from each. Is there any one of these choices that doesn't have 2 from each? I'm going to ask you to look because I don't, like I say, Weber, May. Okay, I'm just going to look and see. Weber, May, Oakes, Wright. Weber, May, up. That one's not it. Yeah, this is just deduction, I would hope. So you would mark that one out. Why? Because there's 2 from the same team. Same thing here. You got Weber and May and Oakes again. So we're just using deduction. So when you read this question, you might think that, like I thought, it is misplaced, but it's not. It's just deduction. Let's look at the other ones. Hadra, Lukens, Pollack, and Carter. Hadra, Lukens, Pollack. Nope, can't have it. Remember me telling you that Hadra, Lukens, Pollack. So all 4 of these are out. Why? Because you have to read the question. Remember me telling you that a lot of probability and statistics is not math. It's reading the question. Okay? And it says right here, the panel should consist of 2 members from each what? There's your question. And a lot of people ignore that part, or they just go over it and they don't read it, and then they don't understand they don't understand the answers. You see what I'm saying? So in this case, this is a standardized test question. It's not, I've never seen this question before. So it must be a new question that they've added. So this is just law of deduction. Capiche? Okay, nobody's going to talk, but that's okay. Turn the front light off, please. Pretty please. So it's not a misplaced question. It's just a question that you have to read. Next. Be so glad when we get in math. 1.4, 10/6. 10 in the book, 6 online. Determine whether the following statement is true or false. When obtaining a stratified sample, the number of individuals included within the stratum must be equal. No. All right? there's some things in, and I might have told y'all this the other day at the end of class, or it might have been yesterday's class. There's some things in statistics that there's some words that you stay away from. Everything is equal. Now, what about random? Everybody has the same chance. And the same chance and equal sometimes contextually are not the same thing. Equal is one of those words that holds you down. Let me ask you this. Who in here is perfect? Why didn't anybody raise their hand? Okay, that means I want y'all to answer it, okay? That's not rhetorical. Why didn't anybody raise their hand? Okay, is perfect a word that you would not use in statistics? Yes, you would not use it. Why? Because it's what? It's unobtainable. Let me give you another example. Write that example down. Perfect is a word that you would never use in statistics. I'm trying to explain a concept here, not just answer a question. Okay? All right? I'm going to ask you something and some people are going to be offended and I really don't care. All right? So here it is. Birth control is 100% effective. I had 3 women go wrong. Okay, I said birth control is 100% effective. 100% you stay away from. Why? Because it's unobtainable. Okay, as far as a product working. All right, you're going to have some defects. You're going to have some person at the factory that messes up something. Okay, so the product comes out defective, whatever the product is. Everybody see what I'm saying here? All right. So when I say, here's another example of something to stay away from. On a scale from 1 to 10, that test was a 10. No. You might say 9.5 or 9.8. But again, going back to that perfection. When you're doing a survey, do you want everybody to be the same? No. So that's where this question is going. Anytime you pick a cluster or a clump or a stratified or whatever, you want to pick from different places. Okay? So if I want to do, let's say I want to do a survey in Anderson County. Am I just going to pick West LA? No. I'm going to go West LA. I'm going to pick 25 people from West LA. I'm going to pick 25 people from LA. I'm going to go west of Anderson. East of Anderson, south of Anderson, north of Anderson, and then I might go downtown Anderson and pick some people there. You see what I'm saying? I don't want to say, well, I'll just go to West Anderson because that's where I live and I'm just going there. That's not where you... So equal is one of those words, when you're talking about surveying people, you don't want to just pick somebody because they're the same. The same, another word. You don't do things that are the same when it comes to picking people. Okay? So when you're reading this question, you know when you see that word, the number of individuals must be equal. No, it does not have to be that way. Okay, so that takes out C. All right, and then of course, let's look at when they take a stratified sample, a symptom random sample is drawn from one stratum. All other strata will not be included. All right, what's wrong with this statement? You just going to throw away? You going to throw away part of your sample? No, you're not going to throw away part of your sample. Okay, so that statement should, when you're in a statistics class, that statement right there should say, I don't know about that. Let's see what this one says. False. A stratified sample is constructed by successfully selecting a stratum of random and then selecting a random individual from that. With this process, it is unlikely that all strata will be sampled from the same number of times. Now, do you remember the old cliche or the old saying that with each question, there's 2 that you can get rid of and there's 2 that are similar? Okay, well, D is similar to B. But when you read B, within stratified sample, the number of individuals sampled from each stratum should be proportional. That's a word that statisticians love. Write that word down. Proportional. Proportional. That's the dead giveaway right there. Now, like I say, this is not a test question, Hubert test question. This is I wouldn't even think this would be on a standardized test, because not many people really walk around thinking about a stratified sample, unless you're a statistician. Okay, so the key word here is proportional. 1.4, 27 in the book, number 14 online. We went over this the other day. This is the NPK. Okay, we went over that. I'm going to just hit it right here. And we went over it yesterday too, so you can watch both the videos, okay? I'm just going to go down here. We know that big N is the big number and little n is the little number. And I'm just going to go down here, and they're supposed to give you the formula, but they didn't. Okay, well, there it is. The first one is N, and then 10 plus K, and then 10 plus 2K. So there is the formula right there. I'm not going to spend a lot of time on this. Like I say, I went over one. What day did we come back? Tuesday. I went over one Tuesday. I went over one yesterday, and I'm not going to go over another one because this one is misplaced. It should not be on a standardized test, and it should not be on my test. So just like I say, take the first number, big N divided by little n, that's equal to what? K. Then K and 10 plus K and 10 plus 2K. .4, 27/14. Okay, again. So there's the same thing. I'm not going to go over that one again. Let's see, 27/14. This is 1.2, 3/2. I think we're getting into stuff that we've already done, haven't we? Yeah. Yeah, we already did that one because that one is misplaced. That's the other question that's misplaced. I see I hadn't clicked on this one. So let's look at that one because that means that this one, and this one was Friday the 17th. So that means this one was sent last week. This is 1.51/1. 1/1. What is a closed question? What is an open question? This is a good question. Okay. In research methods, when you take, let's say you're in your third semester at Clemson or wherever you decide to transfer, you might be taking a class called research methods. And one of the things they talk about is the questions that you put on a survey. Okay. And the questions that you put on a survey, I might have used this example. You're not going to vote for John Smith, are you? Is that a good question? No, that's a leading question because I'm trying to get you to think negatively about the question as I ask it. Okay? You go over what types of questions to use. And one of them is open question versus closed question. And I'm just going to give you the definition. The closed question has a fixed choice of answers versus free response. So is this a closed or an open question? Closed because you have A, B, C, and D. What is your favorite color? Blank. Is that open or closed? It's open. So write that down as an example of open. How old are you? Blank. Anything with a blank and it doesn't give you choices is a closed question. I mean, open question. Anything with choices is a closed question. That's a good test question, and it's a good standardized test question. And I think I've already went over these, but I'll check. 1.2, 19/10. Yep, we already did that one. So I'm going to go ahead and delete those, and that way we can open up a new set of questions when y'all finish. Hopefully we get to math soon, because I'm about peaked out on these vocabulary questions. It's not my cup of tea. All right, here we go. A Pareto chart is a bar chart in descending order. That's all it is. Now, if you want to use the word histogram and impress people, then go right ahead. But it's a bar chart in descending order. And I'm not a big fan of Pareto charts. I like to see the way that the data is. Personally, I like a dot, a scatter plot, or a line plot. I don't like bar charts or Pareto charts or anything like that. I like to see the actual cluster. That's just me. And here's an example of a Pareto chart. And that's the M&Ms. We started on the M&Ms, didn't we? Yeah. Okay. So they don't have, see, you could have the colors in what? Alphabetical order. And then it wouldn't look like this. So this is a Pareto chart. This is a standardized test question. This is, I bet you $1 if you take a standardized test question, they're going to ask you about a bar chart, about a histogram, about a pie chart, and a Pareto chart. They're going to ask one of those. And we talked, must have been, I can't remember if it's this class or the last class or yesterday's class, but we talked about this. When you have two sets of data, write down a sidebar is usually two sets of data. And it's easier just to see it this way, okay? Side by side. When you have a side-by-side chart, that's usually with two sets of data. More than two sets. And that's about it on that one. Horizontal bars, you don't see horizontal bars a lot. You see horizontal bars, it's just a preference, especially if you've got a lot of data. If you've got a lot of data, then you might want to use a bar chart. Why? I mean a horizontal, because landscape is longer than what? Portrait. That's basically it. So for some of you computer people, just think of horizontal, the same reason you use landscape versus portrait. Horizontal is longer than what? Vertical. You don't have to, just write down a horizontal chart just equals landscape, more room, a lot of data. And there's your pie chart. And this is a test question or a standardized test question, but you will see either a bar chart or a pie chart on my test. Now, you're only talking about 20% of the test comes from Chapter 1 and Chapter 2. So I've already told you about 3 or 4 questions you're going to have. 1, quantitative versus what? Qualitative. Discrete versus continuous. Pie chart, bar chart. And parameter, population, statistic. I mean sample, statistic, lowercase. And then the Definition of uppercase statistic. Those are 5 questions right there that could make up the whole test from chapter 1 and 2. Unless I see some more that I like to put on the test. Oh, I'm trying to go as far. I already told you about classes. Classes go with quantitative. Categories go with what? Qualitative. Blondes, brunettes, and redheads. That's your qualitative. Classes, age groups. That's your, or boxing and wrestling classes. We're not going to do this. And I'll tell you right now, I'm not going to give you 50 numbers on a test. That's ridiculous. I might give you 10. Now, there are some times when I'm doing a 5-number summary, and I question you on 5-number summary, which if we ever get to chapter 3, we'll go over, but I'll give you like 15 or 20 because I have to give you more than 5 to do a 5-number summary, and 10 is not enough. So I have to give you more on those questions, and those are easy questions because you can do them on the calculator or the Excel spreadsheet. I'll show you how to do that. So I'm going to skip through this. There is, I'll give you 10 or 12 or 15, and you have to do that. So, if you want to take a second and write that down, that's a test question right there. To be able to take a set of data, put it in order, and then give me that's basically a frequency distribution with relative frequency. So I'm going to give you a second to write that down. But I will not give you, that's a homework question. But on a test, I'll give you 10 to 15 to do like that, I hope. And there's one question you're going to get in chapter 3 that's going to have like 15 parts. So, and I've already got some people sending it for me in the 103. They're already sending me homework questions about it. I just have got into the math with 103. So the reason 120 is behind 103 on speed is because y'all's chapter 1 and 2 is spread out longer than the 103 is. So I'll give you another minute or two to write that down. And the only reason you need to write it down is so you'll have an example. Give you a second or two more. Everybody got it?
Almost.
Almost? Now this is a test question because it's a little bit of math. This is not vocabulary, so I'm not counting that as the chapter 2/3 questions. This is a chapter 3 question because it's that math involved. A little bit of math, but you will have one on the test like this. Got it? Okay. Oh, I'm not even going through histogram. I'm just going to show you. There's a histogram. And the difference between a histogram and a bar chart, the bars touch. Okay, I'm not going to spend a lot of time on that. Make sure you know the difference, though, because on the standardized test, they'll put which one is a histogram? And they'll give you A and B. A is a histogram and B is a bar chart. So on a standardized test, they would do that to you. So make sure you know the difference. As far as mathematically, there's no difference. Classes, we've already talked about that. Classes are with what kind of data? Quantitative. Weights. Weight classes. Weights are quantitative. There's your weights. Now, did we talk about class width? We talked about that? Finding the class width, class boundaries, all that? Okay. So let's go over this right quick. Somebody tell me what the class width is. 10. 35 minus 25. 35 minus 45, or whatever. 44 minus 34. 54 minus 44. That's the class width. Somebody give me the midpoint of the first one. Well, 25 plus 34 is what? 59. Half of 60 is what? 30, so that'd be 29.5. So 29.5, then add what? 10. What's 29.5 plus 10? 39.5 plus 10. 49.5 plus 10. And those are your midpoints. Now, you can add up each one and divide by 2 if you want to. If you like whips and chains, just go ahead and do that. If you like pain, go ahead and do it. Okay, you just extra time. Or you can just add the class width to everything. Class boundary. Are these whole numbers or tenths or hundreds? Whole numbers. Whole numbers goes to the tenth. So that'd be 24.5 plus 10 is 35.5. 34.5 plus 10 is 44.5 plus 10 is 54.5. Plus 10, 64.5. That's your class boundaries. That's a test question. So, you know, you don't have to write everything down. Just write down class width, midpoint, and boundaries. What if it was 25.0 to 34.9 and 35.0 to 44.9 and then 45.0 to 54.9? What if it was those? That's to the 10th. So my class boundary would not be to the 10th, but to the what? 100th. And then that's when you switch from 0.5 to 0.95. So if this was 25.0 and 34.9, then you would go 24.95 plus 10, 34.95 plus 10. So when you go to the 100th and the 1,000th, you don't use 0.5. You use 0.95 and then 0.955 and then 0.95555. You got it? But usually I don't give you anything but a whole number, or I'll give you the 10th. I don't take it to the 100th. So you're going to use 0.5 or 0.95. Capiche? No sneezing in class. That's all right. And that's another, I'm not going to ask you to do that. We're not going to do that. Stem and leaf. Write this down because you're going to see this on a standardized test. Now, I'm not going to have you write down the data. You can if you want to. I'll go ahead. Well, I'm not going to even show it to you, are they? There it is. No, we're not doing that. Okay. But what is a stem and leaf plot? Well, if they're ever going to show it to you, there it is. Use that as an example of a stem and leaf plot. How many 20s do we have? We have one number that represents the 20s, 28. How many numbers do we have that represent 30s? Well, golly, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 38, 38, 38, 33, 39, 32, 39, 32, 32. How many numbers we got representing the 40s? A lot. 47, 48, 42, 40, 43, 40, 41, 40, 44, 47, 40, 46. Everybody see what I'm doing? You got a scale on the left that represents the tens or the hundreds or the thousands. And then the numbers on the right represent the ones. Do you have a question, Mr. Ramsey?
Yeah, don't you have to have a key for it though?
What do you mean, a key?
Like, because for this example, it would be the decimals, so it'd be 2.8728, so what you have to put.
Well, yes, I'm just saying the actual stem and leaf plot is based on the numbers on the left and the tens, hundreds, and thousands. So if this was decimals, it would be 2.8, 3.8, 3.8. I'm just using the tens because it's easier for you to grab hold of. Okay? But yes, you're right, Mr. Ramsey. You do have to put it in context with the data. In that previous slide with all the states, the 50 states, you had this like 3.8 million, 4.8 million. So this is decimal. And the key is 3.8, 4.8. This is decimals. But I'm showing you what a stem and leaf is based on tens and ones because it's a whole lot easier for you to grab onto. All right? So in this case, how many 70s do we have? 1, 75. Or, in this case, like Mr. Ramsey said, 7.5. Everybody with me? So now you're going to see a stem and leaf plot, and then you're going to see a dot plot. A dot plot replaces the numbers with dots. So how many numbers do we have for 30 or 3 point? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers that represent 3.0. Okay, 3.0 to 3.9. Everybody with me? Or 30. In a dot plot, you would have dots there. You would have 9 dots. Or let's say just check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you would have 9 dots there. You would have 10, 11, 12. 12 dots here, 1 dot here. So if you was to do a dot plot and put these side by side, because it's 2 standardized test questions, but it's not that difficult. The only thing with a dot plot is you really don't know what the numbers are. So 2, 3, 4, 5, 6, 7, 8, and then there's 1 dot here. Some people use asterisks, and they'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. So that's a dot plot and a stem and leaf plot. You can have the dot plot inverted and put it on the side. Your dot plot can look like this. And you can have 2, 4, 6, 8, 10, whatever. I'm sorry, 2, 4, 6, 8. And then have 1 there. Oh, I'm sorry. That's not right. It's not 2, 4, 6, 8. 2, 3, 4, 5, 6, 7. And have like that. Like that. So a dot plot can be on the side or it can be vertical. Again, these are only things that you would be asked. I'm not going to ask you to make one, but you could be asked to do that on a standardized test. Yes, ma'am.
Since you have like the same numbers like 40, like it has tons of zeros, how would you like do that for the dot plot? Would you just be like side by side or?
For the what?
The dot plot, like since you have all the 40.
Okay. You got to remember, this is showing you the values. Okay. There's 32, 32, 32, 33, 38. On the dot plot, it just tells you how many numbers. Okay? So how many numbers do you have representing 3 point or 30? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 dots over here. The difference between a dot plot and a stem and leaf. Stem and leaf, you actually know what the numbers are. Dot plot, you have no idea. Okay? Does that answer your question? So you don't know if this is a 31 or a 3.1. You don't know if this is a 32. You don't know. So, but that's the difference between the two. The main reason you want a dot plot is so you can actually see the what? You can see the curve. That's why you use a dot plot. But you can still see the curve if you just use your imagination. See? And just turn it on its side. So it really doesn't matter. That's pretty good with a mouse. I suck at drawing with a mouse. You ever tried it? It sucks. Here's where you, again, this is not, I'm not going to ask you this. This is when you break it up. You got more than 5 or 6 numbers per, so you break it up into 20, 25, 30, 35, 45, 40, 45, and then you give the numbers above 5 or below 5, whether it's 3.5 or whether it's 45 or whatever. So here, I've got a 2.8, and then on 30, I've got a lot of numbers with 30, so I'm going to break it up. Now, I don't like doing this. Can somebody tell me why you would not do this? Anybody? Because it messes up your what? Your curve. You can't see the curve as well because you're busting up your groups. So the curve here is, what happened? What happened? There we go. The curve here, is this a true curve? No. This is not a true curve because you're busting up your groups. Does that look like the curve we had before? I have no idea why my line is going to the left like that and coming back. I don't know. Maybe it's the Russians. That does not look like the curve we had on the previous. Some of y'all are bored out of your school. I know. I'm going as fast as I can through this, okay? There's your dot plot. See? That's your dot plot. And, of course, you can see the curve a whole lot better. So what do you need to know about this? You need to know how to read a dot plot and how to read a stem and leaf plot. And what's the difference between the two? They'll give you a dot plot and a stem plot, and they'll say, which one's a dot plot? Simple question. Now, when you get into more advanced statistics, like a 3rd or 4th level statistics course or research methods, you get into actually building them. But it's not that big a deal in those courses. Write this down. There's 4 types of distribution. And we're going to get into this later in chapter 6 and 7. But it's very important that you understand what these are. Uniform. Just put time and put rectangle. You ain't got to put all that. Put time and rectangle. What's the only thing we cannot control? Time. Even though some women try, and it's really sad. Y'all ever been to a cheerleading or a dance competition?
Yes.
Yeah, some of the women try to dress like their daughters, and it's really sad. Y'all know what I'm talking about. Don't act like y'all don't. It's really sad. Uniform distribution looks like this. It's always a rectangle. The volume under the curve or the rectangle is still 1. We'll get into that, chapter 6 and 7. Okay? Bell-shaped. Put normal. That's the normal curve. Bell-shaped is usually what 80% of statistics works with. Probability of statistics. Okay? So, uniform distribution, time. Anything having to do with time. Normal distribution usually is 80% of what we work with, and that's the word that goes with that. Skewed right. Skewed right means just put all the materials to the left. And then put a dash center line. Skewed right means all the material on the left. Put this as an example. Everybody failed the test. You ever had a class where even the nerd that sits up front that makes 105 on everything, he even failed the test, or she even failed the test. If you ever had a class where everybody made a 40 or a 50 on the test, that means one of two things. That means the test was invalid, meaning it was the wrong test. It means the teacher sucks. Or what? All the students suck. Well, that's going to be, what's the number one rule of life? There's always what? There's always one. There's always one in the group that's going to make 105 on the test, and it could be in underwater brain surgery, and that person would make 105 on the test. Okay, there's always going to be one person that messes up the curve. There's always going to be one person at work that screws it up for everybody. One person in the classroom that screws it up. There's always one. So, if you get a 45 average, then everybody made an F. Everybody. Then that tells you something is what? Wrong. What about skewed left? All the data is on the what? And that means everybody what? Everybody made an A. And that's impossible because y'all live PD. How many dumbasses are in the world? Okay? One person is always going to fail a test. I don't care how easy you make it. And I've proven that in some of my classes. Okay? Because of two things. DAD and LAD. Lazy disorder, and you fill out the other one. Okay? So that means something is not right also. If everybody passes, that means the test was too easy, or the instructor is just fabulous, or the students are just shining in glory and they're just all gifted and talented. But the third one's not going to happen because you always got live PD students. Okay? So this is very good for later. You might see it on my test. And I know you'll see it on a standardized test. That's a good question, but we're going to see that later in Chapter 6 and Chapter 7. So you see, when I actually like something, I actually talk about it a good bit, or when it's valuable. And I don't know why this thing's not turning into a... There. Sorry. And there is your examples. So I'm going to leave that on the board for a second. And you can just, if you watch the video for that one person that watches it, you can pause it. Okay? I didn't know they were going to put a slide up there. I would have just left that one up there. But you can see uniform, bell, skewed right, skewed left. So I wasn't crazy when I did the opposite way. You know, skewed right, all the data is on the left. Skewed left, all the data is on the what? Right. And it's usually good to put a center line on your skewed left and skewed right. So that way you know that one is skewed left or skewed right. So you would dash in a center line right in there somewhere. Comprende? Now, what about this one? Well, it has no shape. Always do this with your graphs. Draw a line. Does that have any type of shape? No. So it's not normal. It's not skewed left. You might could argue that it's skewed what? Left, because a lot of the data is on the what? It's on the right. So you could argue that it's skewed left. So that's what it would be on my test. I give you a shape, You tell me what you think it is, or it have A, B, C, and D. Make sure you can do a dot plot. I'll show you how to do that on your calculator and your Excel spreadsheet in Chapter 3 if we ever get there. What did Mark Twain say about statistics? Because I think you need to have both sides. So let me have literature English people. What did Mark Twain say about statistics?
You have a work email.
That's what he said.
He said there's lies, damn lies, and statistics. Okay? So you got to have both of them. I don't want to just give you one that gives you all the glory. There's also people that use statistics in a not so glorious way. But the science that enables different experts using the same figures to draw different what? Conclusions. Okay? Now right now we got something going on right now that has to do with different conclusions. Okay? And that's the impeachment. Okay? You got one group of people that says the president did something bad. And then you got one group of people that says the president didn't do anything bad. And the evidence is the same. So that's judicial or politics, but statistics is the same way. You can have the same data. Y'all ever seen the commercial where I hate the commercial, but the State Farm commercial with the guy in the suit, the blue suit, and he goes to the psychiatrist and he keeps seeing this dream of a football team, and y'all seen that commercial? Oh yeah, that's right. Y'all don't watch TV. So anyway, he says, what does this mean, doctor? And the doctor says, you need to do this. And he said, well, that's the wrong conclusion. He asked the doctor, but he don't want to believe it. All right. Same thing happens in statistics. Some people just don't want to believe it. No, you don't have to write that down. That's kind of just something. There's all kinds of sayings about statistics. Misrepresentation of data. Does it happen? Yes, it does happen. There's two reasons. Give me the two reasons. Anybody want to take a guess? Bias is one. Human error is the other. Let me give you an example of human error. You got a mathematician that works for blah, blah, blah research company. And the New York Times tells the research company they want this survey done, blah, 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 blah. They give them, the mathematician and the researchers do the math and give a report to the New York Times. The New York Times takes the report, prints it, and then they give the data to the graphics guy in the graphics room. Okay? Does the graphics guy know probability and statistics? No. He takes the data, does a nice little pictograph, but he does it wrong because he doesn't know. That is a mistake. Okay? Let me go back to my example of going across the United States and predicting the next senator. Okay? I go across the United States and I say John Smith is going to be the next senator, blah, blah, blah. But I went across South Carolina, Mississippi, Georgia, Alabama, Louisiana, Texas. I went through the south of the United States. Again, that is being biased. And you have both. So you got to know how to tell when something. And usually it's with graphics. Write that down. Misrepresentation is usually with graphics. These two are giving you the same data. Which one's correct? Got one person says A. B is correct. Why is B correct? Starts with 0. Look in the lower left-hand corner. Now, why would you use the one on the left? What do some people love? Drama. Okay? Y'all know the people in your life that loves drama, right? Okay? Same thing with people in the media. Okay? I don't care. People say, oh, you're jumping on the media. I'm talking about newspaper. I'm talking about radio. I'm talking about TV. I'm talking about, they want you to do what? They want you to buy their whatever. What looks more exciting? A, shows more of a drastic increase. When in reality, is it a drastic increase? No. This would be marked probably bias, because everybody since the first or second grade knows if you draw a graph, you start from what? Zero. I'm going to show you another one. I hope they put the, I'm not going to go through this. I want to show you the graphics because that's what. All right, first of all, why would you not use this? You can't see the what? You can't see the chart. You need to tilt it. So that's a misrepresentation. That would be probably a mistake. I mean, just a mistake. Somebody not knowing how to use the Excel spreadsheet. Okay? Or not knowing how to present. When I first started at Tri-County Tech, I was asked to do a report for the department. Oh man, I went crazy, okay? A math teacher doing a report. Oh, I had graphs. I had about 15 graphs. I gave it to my supervisor. This ain't gonna work. And I was brokenhearted, okay? I was like, I did all this math. I had at least 15 charts in there. You know what she told me? She said, whenever you present, you always present on a 5th or 6th grade level. Always present on a 5th or 6th grade level. Unless you're reporting or presenting to your what? Colleagues or peers. Then you can be a little bit extravagant. But when you're presenting, if you're a math teacher or a statistics person, and you're presenting to people that don't live, breathe, and then you present on a 5th, 6th grade level. So you need to cut these 15 down to about 3 charts and make them to where a 5th or 6th grader could read them. That's one of the best rules that I've ever been given in life. A presentation needs to be on a 5th, 6th grade level. So when you're doing an Excel spreadsheet, does all this glorious stuff actually pay off? No. Keep it on a 5th, 6th grade level. And make sure you don't lay your pie chart down where you can't see it. Okay? That's the one you want right there. I got a couple of more I want to show you, but we don't have time today. Was that the end of chapter 2?
Yes, sir.
Hallelujah. Okay, so that's a good place to end today. Let me call the roll because I've got to get